All right. Before we start today's lesson, I saw Burma's pull request. Still got to review that. Ish, you got to review that too for me because you're one of the PR approvers. Fi, I didn't see a pull request from you. Do you have any issues you want to go over now?
Oh no, I did it.
I didn't see. I didn't see any. Let me check. You put up a pull
Mom is
request?
German.
think I forgot to do that part.
And they,
Oh, you forgot to create a pull request?
Yeah.
That's fine.
Yeah.
All right. Yeah, just send it. Do it after the class. But what'd you think? Did you
I
What'd you
think this
think of?
homework will be easier. I did get a little bit of help, but not like with like the logic.
Yeah.
With like like organizing and stuff because I had to make a separate utils class
Yeah.
and certain things I was a little confused on. But in terms of the logic, I feel like I understood it.
Right.
I didn't really need help with that.
Yeah, that sounds good. Yeah, I just wanted to get you guys start getting used to the idea of classes. I know Berm started using it early, but I don't want you to do that for a specific reason because if you start with classes too early, and if you look them up, so on to the next topic. So like on classes, the reason why I didn't want you to use them is because the utility is very like it's there's diverse utility, and if you just use them for no reason, you're gonna forget right away, or you're not gonna use them right because even and I didn't want you guys to look up how object oriented programming either because the idea behind it, and I guess I could preface today's lesson with it because today it's gonna be a difficult lesson, not because of the individual ideas, but just overall knowing how to use it, and you'll see what I mean by that. But moving forward, just in the back of your head, have this idea that let me just start with this. So as you can see, I started with a very clean template. The only difference I changed is here is I started with a package called main, and that's just another way to higher level way to group things, just like how you would group in folders. So I just have a think of this as a package, hence this like a little icon right here. But it's not too different from how a folder works. You use them to start grouping things better. And outside of Hello World, I decided to move from that, naming convention and just call it execute. Why I called it that is just because we're still going off the idea that within the main method is where you ultimately want to, execute your functions ultimately, hence execute. Um,
Should we delete our hello world?
yeah, but actually for today, so I should also mention this. Today is gonna be so involved that the new ideas, I'm gonna go throw so many ideas at you because you guys are gonna be out, this week for a few days. So there won't be any homework, but what I do want you to do after this, just to give you a like brief overview, it's gonna be it's gonna use like the actual you'll see the actual engineering side of programming, like in that programming, a lot of it is really just keeping things ordered and logical for the next guy to read and code. And this is the first time you'll really get what all this public static void, all this this terminology, what it was all for from the start. But what I ultimately want you to do afterwards is there won't be any homework, but I do want you to start from a blank slate like this and try to do it on your own. And obviously, it doesn't mean much right now because you don't know what I'm ultimately referring to. But you'll see how as we build up to it, you'll see the need for some of these concepts. But let's start. So I got the execute class here, and the only other exposure to classes you guys had so far was the utils class, right? And if you remember, originally we called it utils, and we just made all of its like we just made it all of its public static void fun, right? And you just created a bunch of functions, and you used it as if utils was just a class, like like a repository of methods to use, right? And that's one way to use it, but it's not going to really take you too far. It's just to get you, used to the idea of, you could, do utils dot and functional one, right? But say you wanted something more complex, right? All we really used so far was lists, sets, strings, hash maps. And that does take you, that's pretty much all you need to know for stuff like lead code. But once you're actually in the real world, you most likely you won't use much of this. You'll probably use lists and hash map, and strings, sometimes sets, but not really. But you won't really use it in the lead code fashion. Lead code meaning like of what you guys have done so far. Like there's going to be some logic, but it's mainly just keeping things ordered and logically presented, I should say. So the first major example I wanted to get into is how do we take say like this module just has you I don't know, take the area of a square. So imagine a two-dimensional square, and unfortunately a lot of this is going to involve me talking. I'm going to take kind of brief moments of pause, but like because there's so many ideas to be thrown at you, it's going to make more sense afterwards. So don't be worried if you don't get it right away. You won't, because this is a lot to handle. But the idea is we're going to present a small problem, and then we'll see how even object-oriented programming handles it or doesn't handle it, right? So I don't know. Say the best way to start something like this is just to present a problem and figure out how I would execute it, right, in the main function. So say I wanted to take the area of a square. What's anything that pops in your head? You're not gonna. There's not a wrong. This is just a hypothetical. Like if I wanted to get the area of 5 squares, how would you do it? Like I'll take any answer. I don't care. Assume all you have is a main method. Yeah, go ahead.
You would ask what's the sides or what's the length of the side?
Yeah,
The
right,
length and width,
right.
and then you would
So
put it into an
like this,
integer,
right?
yeah,
Int
and then you
length
would multiply it.
int width.
Multiply the two integer. You would print out the multiple of the two.
Okay.
Yeah.
All right. And let me see. Why is this? Oh yeah, you gotta initialize it. So right, and you would put let's assume 3 by 3, right? So okay, and that would give you 9, whatever. What if I wanted what if I wanted 5 different squares and I wanted you to find all of them, the area of all of them? How would you do it? And just think of presentation. Like think of the word presentation, in that there's no wrong answer technically, but keep going with whatever you're gonna say.
Well, a long way would be just to do the same thing for all 5.
Well, how would you present the idea of 5 squares with what you know so far? Anyone pitch in here.
Hash map or something?
I mean, yeah. I mean, you could do hash map, but then like
Square one, and then the key is like square one or square two, square three, and then the value is like the areas of each.
right, but you're saying that there's no. For instance, we could do that. I get what you're saying, right? But it's very weirdly presented, right? Like I could do integer, like we went over, right? Integer, whatever, map, and it's very abstract still, right? There's no. It's not like English. Like if I were to tell a 12-year-old to give me the area of 5 squares, he could present it on a thing, on a piece of paper, and whatever we're trying to do right here. Like let's say my solution to this question was like, all right, let me just assume length 1, width 2. Let me just assume length 2, width 2, right? And I could say, all right, assume the following is square 2. Assume the following is square 1. You see, that's one way to do it. Technically, yeah, you could do it. I could assume X, Y, and Z, but it doesn't take a genius to realize like this is very inefficient. And if I'm an outsider looking in, I don't know what the hell you're talking about, right? Length, width, one. That could mean just about anything. That could mean like length of a, I don't know, like a person, width of a person or a boat or something, right? There's no direct way of doing it. So what classes let you do is we actually start making it like give it more structure, right? We don't have to deal with integers because in the real world, you want to cover all this up, right? You know a square has a length and a width, right? But why am I going to present it here? So just to make a long story short, this is where classes come in. So right here, our first class will literally be about squares. And actually, before I even continue with,
you want us to create the class?
no, I honestly like just kind of pitch in. I'm gonna try to throw as many questions at you, but I just want you guys to pay attention because ultimately, in the end, remember you're gonna recreate this entire framework. And just to give you a quick, just to give you guys that that idea of what's it gonna look like. Ultimately, this is what we're gonna do. Don't read too into it, but at the end, we're going to create a very tiny framework, and this has to deal with my the example I have intended, but there's a lot of stuff here, right? But we're going to cover all of it, right? So don't worry, and you'll see what all this means. But basically, if you see on the left side panel, it's really starting to look like an actual code base, not like one class, because in the real world this is not going to be the case. It's going to look like something like this, right? If you were to look at this from a like a bird's eye view, you'll think it's a an actual like code base. So this is the end goal. I'm just using that for reference. I typed this out before. Everything is logically coherent, and that's what I'm kind of going off of. But that's gonna be our end goal. But like I was saying, I'm gonna comment this out right here just to show the utility of classes. So what classes do. So I'm creating a new class here, and I'll call it square, right? And without even populating the body, let's just do something like this. What does this look like to you guys? Like, what's the first thing that pops in your head with how I presented it right here?
Object.
Like an object, right? Like we went over lists, sets, strings, hash map. This is no different. Hash map, strings, sets, list, somebody else created that, right? Let me just put that here. Assume an integer. So just like someone else created the list for us to use, we're going to create a square object for ourselves to use, right? Because there is no square object. There might be, but it's not in the it's not in the Java development kit. It's not in our library. So this is where you start becoming the builder. Where previously you used other people's objects, right? Their classes. Now you create your own. It's like your own workshop. You choose to go how the end user uses it. So this is like me, for instance. If this is a worthwhile class I created, I could create my own library, and I could export it out to Fa, who could use it in his code, right? And just like list has its own. And what I mean by that is every time we use list.add an integer, we didn't worry about the inner mechanisms, right? Why didn't we? Because if we control click this, just watch what happens. This is no different from looking at, so right now we're in the list class, right? And you can see it's natural. Look at all these things. Let me see if I was looking for actual code, but the way they abstracted it, you won't see any actual code because all that stuff, it belongs elsewhere. And you won't actually, I mean, not should have done that, because this is an interface and you'll know what that is later. Let me click at array list. So look at all these functions, right? This is somebody else's logic, right? Even something as simple as add, let me see if it's there. So see, just like that add function we used, just like, let me find get, add, all these you're familiar with, but you don't know the inner mechanisms of what's going on here. I don't even know what's happening here myself, honestly. But that's the point of it, right? You do the, it's like the best way of thinking about it is like anytime you drive a car, like you know how to accelerate it, you know how to brake it, you know how to put it on, brake, you know how to, turn on the hazard lights. In your head, that's just clicking buttons, turning knobs or whatever, turning the wheels, but you don't see the inner mechanisms of it, right? Because the engineer did all that, right? But the engineer refers to like the laws of physics to create whatever he does in the library, right? So it goes on and on, right? So if we go up to the upper method, from a class's perspective, it's our turn to be an engineer, right? So to use it on a future case. So as a long story short, let me delete the lists, right? And thinking of how to, or let's say remembering how we used a list, which remember someone else created for us. List equals new array list. How do you think we would, so we have the square now, that's an object, right? It's nothing in it. How do you think you'd prepare to start making it useful? Like what's the first useful thing you could think of with a square object? Like a method.
Getting the area.
Yeah, exactly. This is exactly what I asked before, right? Why go through all this trouble if we have a get area method, right? Right? There's a problem. We don't have any integers to work with. How do we do that? How do we do it here?
Say that again. How do we?
So
if we don't have integers.
Yeah, right. So you got the get area, you got the methods, right? But you don't have any, field data to work with. Like, what does get area mean? Like you said before, it's go ahead.
Do you have to put an input or have them put an input?
Don't worry about input yet. Just think. So the square so far we specified a get area method, right? But yeah, you and I know what get area means, right? But how did the square class know what to use to, does it think get area means, I don't know, return a string? No, right? How do you specify?
You gotta put public int.
Right, I get what you're saying. Right, like that?
Yeah.
Okay, and now what?
And then you put it in the parameters for get area.
It's a good guess, but no, that is a good guess. But remember, we only use parameters when, like, let's say, so this has access to length and width, right? It's in the same class, right? So putting let's say int L, int W here wouldn't make too much sense because remember, just like that's why I had you guys do those utils example, because the only time you put the parameters in is when you intend to use this function elsewhere, right? So yeah, so close.
You would just put length times width, right? In the method.
Right, exactly, right. So it shouldn't be void, right? What should it be?
You just erase void, right? So you do return,
right?
I guess.
Right. You're on the right track.
So you would put like area equals length times width, int area equals length times width.
Like this, right? Oops. Right. So just like the utils we used before, right? You're using exactly. Right. Okay. So we got that right? So technically this is usable. And since it returns an integer, we could do this. Right?
But now there's still no integers. There's still no numbers.
Right, exactly. So how do you think we put it in there?
you you put it into your main, and you
like this. So let's say like that.
No, I don't think that's how you do it.
Yeah, it's not being passed in, right?
I think you do it in the other class.
Right. Keep going.
And you set the values there.
Right. There has to be a way to set the values, and you know, but you guys are on the right track because this is still not something I taught yet. So usually the best way to do it, or the recommended way to do it, right? I could technically do something like this. Set set dimensions. It's a good way to do it. Int length, int width. I could do this, right? And I could fill the methods up. And how do you think this would go? How would I fill this up?
You would. Well, wouldn't you pass those dimensions over from the main class?
So let's use it. So I did use this method over here, right? Which means this is ready to use, in that I could use square dot
add, yeah. Or no, actually it's not about lists, so
public set dimensions. Set dimensions, right? 5. Well, let's say length width because we're passing it here, right? Length width. Now if I were to run this, would it work?
No, because you're
what?
passing.
I'm passing it, right? I specified it here. Let me comment this stuff. So yeah, you keep going. You're on the right track.
That would work.
Say again?
Then it would work, wouldn't it?
So let's see what set dimensions does. Set dimensions, yeah, we're telling it, yeah, you set. It's say again?
There's no logic in it.
Right, exactly. There's no logic in it, right? So you know, you're on the right track. So this is how you interact with this length width. Anytime you're in the actual class, and to differentiate this length, right? Because this is saying, all right, when someone uses this set dimensions method outside of this class, I'm anticipating an integer called length here. I'm anticipating an integer called width here, right? There's nothing in here just yet. In here, there's something. In here, right here, there's a length called 5. There's a width called 5. We're passing that in, right? So this is how you do it. But you know, the problem is they both have the same names. How do you get around it? This is how you specify it. This dot length equals length, right? And if you're ever like kind of anxious about if you're referring to the right one, this or this, just double click it, and you see it'll highlight it. Double click it, talking about this one, right? So the same thing, like that, right? Let's see if it works. So if I were to run this, what do you think would happen?
You print out the area,
which is 25, right?
Yeah.
Right, that worked, right? And to go back to our previous example, over here. Now let's see what we could do. Now, how would you do? Let's how do you think you would begin to let's just pass the number. So before we had them in variables, now let's just do this. Okay. Okay, now how would you get the area of 5 squares? Just tell me exactly what to write.
You would go ahead.
Square dot add.
Where do you see add?
Oh wait, never mind.
You would make 5 objects.
Right. Go on. Let's just say 3 for brevity.
Square 1. Then you do square 2 equals new square.
Right. And finish it up. Right. It's all fine, and you're already starting to see how much more clear this is, right? This length 1, width 1, it could have meant anything. This pretty much tells you, hey, it's a square. I want the area of it. Now continue. So back to the original question, 3 squares, I want the area of all of them. How do you do it?
Square dot dimensions. So you would do a square 2 dot set dimensions.
Right.
Is set dimensions that's a
what?
That's a method that's already available.
Well, what do we define here?
Oh, okay. I'm sorry.
Yeah. So you know how Fa said add before, right? And if you look at it here. If you look at it here, when I put square dot add, he was thinking of a list, but we didn't define a method called add, so it's obviously not there. Set dimensions is there, right? And I'll complete it for you.
You do it for the third one too.
Yeah. Let's just say 23 and 2. I mean 23 and 23, and obviously you just one by one. Let me just copy this. Right, and it's already you see more structure, right? You see the name. You're trying to find this is what classes resolve, right? And I think 23 and 23 is too big, so let's just do 10 and 10, right? And then one by one, it'll give you 25, 4, and 100, right? And you could have technically, you could have done it this way. You could have said assume the following is square 1, blah blah blah. Assume the following, but why even why refer to comments when classes provide that much more structure to your code? And to even add on to that, so there's another kind of feature for classes where you see how we did these set dimensions methods, right? There's something called a constructor where it's almost like saying that anytime you define a square, right? The functionality is so obvious that why even have these extra methods, right? So even more brevity, right? There's this idea in programming or any type of coding, not only just Java, anything. The idea is just to not repeat yourself and don't add code when there's no need for it, right? So to add on to that, Java has this functionality. Well, most programming languages do, called constructors, right? And they look like more functions, right? The only difference is you just call them exactly what you call them as a square, right? And this is their purpose. I left it blank for now, but the idea is the purpose of a square is so obvious. Not obvious in that you can do many things with it, but at the very least, it has a length and a width, right? So why waste the space? Why do all this extra work, these extra lines? And right now it doesn't seem much, right? But the more you practice it on smaller subsets of code like this, the more useful it comes to in the future, right? The idea is anytime you instantiate it, get something more done, right? Instead of having to depend on these auxiliary methods, get something more done just from these 3 lines alone. And how you do that is through constructors, right? And since length and width is so essential to a square, why not just do this? And apply the exact. Let's even copy and paste, right? Let's even delete it because there's no need for it anymore, right? So we're getting errors because we referred to it, but you see, we take it out. And the next good thing about it is it tells you, just like a function, how it's expecting parameters, the constructor also anticipates parameters. So just like we did before, 4, 4, 2, 2, 5, 5, right? And it works just the same. There's no difference, except we saved ourselves 3 lines of code.
What method did you delete from the square class?
Let me show you. So remember how we did set dimensions before, right? Right. So the idea is this alone, right? This puts a full stop in that you have to pass in your values to it. If it doesn't even let you, compile. Let me show you again. Right? You see how in the square class, like since it's expecting a length and a width, right? It doesn't even let you pass. Like, yeah, you could put a new square out, but since you're not putting anything in as I intended, right? You can't move on from here, right? So what's the purpose of this really, right? There's no need.
You just put I gotcha.
Yeah. So it's more like a, what they call it is a compilation problem, and that the last thing you want, especially when you have a lot of code, is after you hit run, you don't want to hit a bug there, right? You want to hit a bug right here where Java can track it, right? That way it's easy to fix and it takes much more, time saving. 5.5, 3.3, or 4.4, 3.3, right? Then you get the area, etc., etc. And this is a small foray into classes, right? So the next idea, just to go off this, don't repeat yourself, keep your code short, and just to have that whole idea in your head. Before we even continue, let's have a shapes package, because the next shape we'll go into is a cube. And there's a specific reason, I'm sure you guys can surmise it, why I went for a cube. Right? And already, even as a, just to prepare, I'm not even creating the classes. I'm starting out with the packages first, because I'm anticipating structure. The best way to do it is keep all your classes short, right? And let's even move this square over. And you see, anytime you do that, the idea of, let's cancel for now, the idea of structure is so important. Java Eclipse has a built-in listener that anytime you move objects around, not only does it say copy and paste it or copy paste delete it, it's saying update references to it. So if I was referencing to the square in this main method, I would hit an error if I just moved it over, right? Because it's moved to a different package. So obviously, for the most part, you want to keep that. You want to click OK to this. Let Eclipse handle it, right? So you see here, right when we did that, it said import shapes.square. Import shapes, referring to the package. And anytime you create a package, you want to distinguish it, right? This is why case is so important in any form of coding. Anytime you see a small s, a small letter to start, it's usually referring to a different package. Square, big letter, refers to a class, right? And it did that automatically. I didn't put this line here, right? All right, so we got let's take out the set dimensions, because you guys get that idea of it, right? All right, so what can you guys tell me about a cube?
We need 3 dimensions.
3 dimensions, but what's the relation to, it's a shape, but I could also create a triangle shape. What's the relation, what would you say a cube's relation to a square is as opposed to a triangle? Let me put it that way.
All 3 would be the same number?
Right, like length, width, and depth, right?
Yeah.
Right, and you don't have to worry about, you know how a triangle could have angles, right, to it. There's no angles to worry about for cubes. Like the length, width, the only difference to a cube is it borrows those parameters from a square. And think of everything I say, just keep it in mind. Like when I use borrows and stuff like that, like terms like that, I'm trying to paint a kind of relationships to you, right? In that a square, intrinsically, without even if you guys, without having to verbalize it, if you imagine a cube and you imagine a square, you see some relation to it, right? You see there's definitely some kind of relation. And anytime you see something like that, and I gotta keep hammering that point, which I'm gonna start now. See, the idea behind software engineering, the main kind of point of it is to exploit those relationships, because ultimately it makes your code more much more functional and easier to code with. And that's, like I keep saying, that's more of a challenge to do than stuff like lead code, because it all ultimately leads to less problems, and it makes your code easy to fix. And that's usually the biggest problem with in the real world. Most of the times you're not adding new features, it's just you're working on bugs. So clearly there's some kind of relation from cube to a square, right? So so just like we have the cube here, let me just whittle this down to one square, right? What would you say the one difference between the cube and square is? It has depth, right? Mm-hmm. So we could do something like this, because it does have a length, technically. It does have a width, technically, and now it has a depth. And if I show you the difference between a cube and squares, at least with the feel so far, let me just put a public there. That's the only difference, right? And just like a square, it has its own get area, right? So someone want to complete that one for me?
Public int get area. So are you trying to get at the point that for length and width we could just call upon the rectangle class? I mean
cube, you mean?
Yeah, square class.
Right. So let's get past the idea of that. Like, obviously you don't need setters anymore, right? Like, you know how what the earlier methods we deleted? What did we say we could use right away to avoid excessive methods where you had to set length, width, and depth? What did we say we use? Like, for instance,
when you create that object pass it.
Right.
You gotta use this length.
Say again?
This length. This
right.
dot length.
Right. What do you remember what that the thing was? What in here do you think we use?
Yeah, you gotta put in
this whole structure right here. I'll put the definition, not the definition, but the term for it. This is called a construct, and it's very important. It looks just like a function, but because an area is so intrinsic to the idea of a shape, right? We do it right away, right? Because like we said before, you don't want this, set dimensions method here, right? If there's no need, why put it there? It bloats up your code. So you what do we do?
You gotta do a public cube.
Okay.
Int length, int width, int width.
Okay. Right.
And then you do this dot length,
which is referring to this, right? Yep.
This dot width equal width.
Right.
This dot equal depth.
Okay. How do I get the?
Just do return length times width times depth.
Right. Right. No errors. And just like sorry. And just like before, how would I get a? All right, let's specify what I would write right here to get the area of a 2 by 2 cube. How would I do it?
You write cube equal new cube. Parentheses. You write 2, 2, 2.
Right. And don't worry about that. It's just importing, right? Because it's that's something you guys will have to get used to from now on because we're using packages. So just because if it were in the same package, it would have just ran it for you because it could track it, right? But because it's in package from now on, you're gonna have to start letting Eclipse import classes. But go
on. Then you do system.out.println parentheses. Cube get area.
Right. We're expecting 8 right here, right? Yeah. Okay. But now going back to it, now I'm gonna look at. There's a lot of repetition here, right? And going back to my earlier point, I don't want that. I want to emphasize the idea of if I specified it here, and if we agreed before that there's some kind of relation between square and cube, I want to exploit that. I don't want to have to write length and width again, right? I know a cube is like, all a cube is, if you want to picture it in a map, you draw it out and you just imagine like, it extending from, the z-axis, right? That's all a cube is, right? So the way we say it is, how do we start? Well, the question is, how do we start bringing that connection to fruition, right? So let's see. So anytime there is a relation, let's start with this. that starts, and you'll see a lot of errors start popping up. Don't worry about that. It's because we already defined everything out, and there's gonna be a lot of errors, but don't worry about that too much. Actually, even better, let me just comment that out so you're not focused on that. All right, so there is some relation to a square, but what is it? So let me map out the constructor just like before, and I won't fill out the logic just yet, just so there's not a million different errors, right? Okay. All right. So since a square already, right, there's already a length and a width to it, right? At the very least, let's what do you think let me ask you guys, what do you think the extends does to this idea of extending from something? What do you think do you think cube has anything to it right now? I should say, like any access to something. Say again?
Code the square.
Say again?
It has all the code from the square class.
For the most part, yeah, pretty much that's it. Like it extends from it. That means it's borrowing a lot of it. It's heavily reliant on it. But the problem is, like, we have a constructor here. The idea is like, how is it affecting this? How is it affecting this? But let's try that. So the idea behind the cube is still the same, right? Just like how I was a class before. Since we're executing the cube here, it's still let's not change the actual functionality. This is what works. Let's not break it, right? So at the very least, what do you want the cube to, at this line, what is it that the cube still needs to be able to do?
It needs to accept width.
Yeah.
The third variable.
Width, length, and depth, right? All three. Like it's a necessity for a cube.
Yeah.
Yeah, length, width, and depth, right? Over here. All right, so how we did that, just as before. Okay. All right, so we got that. But like we said before, length and width already belongs to a square, right? The only thing the square doesn't have is its depth property, right? So how do we handle that? So the idea is, this is where constructors come in handy. So there's this keyword called super, right? And the necessity behind super comes in, it can't act alone. So what super is saying basically, it's saying, yeah, you have this constructor, but remember, I'm extending off a class, right? So yeah, I could instantiate, or I could enact my constructor. But since it's extending, the idea is, since I'm extending, this is going to be executed by default as well, right? And that's not a bad thing right away, right? It's just something you have to really keep track of to make sure there aren't any errors, right? So, but we also got to remember, we're not passing in the depth, right? So if super, I should say it like this: if super is referring to the constructor of square, right? No difference. It's just extending off a square. And I'm telling you right now, if super is referring to the constructor of the square, and it looks like a function, what do you think I pass into it? So take it from like the execute class, right? I'm instantiating a cube. I'm passing it parameters, right? I'm saying these parameters right here, what do you want to do with it? We go, right now, this is the only thing we have written out so far. The length, width, which we have over here, is a 2 and a 2.
Put a square in super?
Say what?
You put square in super?
What do you mean square?
In the little parentheses thing next to super?
Yeah, but where do you see what do you mean square?
Like the class square. Like, can you call on it in the...
So just focus on the only thing over here, right? So what I'm saying is, so forget about square for now. Let me comment that out. I feel like that's confusing you, right? So this is acting alone, right? Just as before, you're creating a new cube. You got a 2 by 2 by 2. That's what I want. I want 8 cubic foot square, right? 2 times 2 times 2, right? It's saying it's accepting a length and width of 2 and a 2 and a depth of 2. Right now, I'm concerned about the length and width because, like I said before, there's a relation here that I'm trying to exploit. And if I'm telling you right here, a cube has a relation to a square, we enforce that, right? And like I said, I don't want to, repeat myself. Cube, the depth belongs to it. Let's even say it like this. We could safely put depth here, right? Just like we did with a square. A length and a width belongs to a square, so let's put a depth in there, right? But I don't want to repeat myself. Remember, we did have length and width here before, right? But how do we pass it to square? Because we already know square knows how to handle it. Now slowly start filling it in.
Well, you did this length equals length, so would it be something similar?
So what if I did this?
So is that saying bring in the length and width from the cube class?
Right, exactly. So
square class?
what's happening here? It's saying, yeah, I'm taking in a length and a width, 2 by 2, right? But since we already see that a square knows how to handle it, just pass it there, right? And hang on. And one thing we forgot to do here is if you have the length and a width, right? We forgot to actually define a third field right here, right? Why not just multiply it? Yeah, we have the length and width. Why not do everything at the same time? Right, so going back to it, you created a square 5 by 5. Let's assume for now. I'm going to keep going back and forth with all the way back to all the way to where we're at right now. So you got a square 5 by 5, right? Let me even comment this out for a second. You got a square. It's a 5 by 5. Let me see what a square looks like. So we put the length here, we put the width here, and we already pre-multiplied the area, right? So do we need this anymore?
No.
What do you think we could do here?
Return area.
Yeah, exactly. All right, so going back, let me comment this out. New square, it's a 5 by 5. 5 by 5. You put the length right now. Basically, this is the blueprint. Think of it as a blueprint. Nothing has happened just yet. And that's something it's hard to grasp at first. This is just a blueprint. The only time it actually starts, doing its magic is right here because you instantiated it 5 by 5. You take that 5 by 5 and you're saying lock this in here, lock this in here, and while you're at it, just calculate the area, right? Such that if I were to do something like this now, it's already there for me, right? And this will give me a 25. Now, all this is saying, now we're going back to a cube, is just walk through it. Let's not even worry about depth for now. Don't worry about this. We got the length and width. Just trace it, right? Super length width. And if I'm telling you, right? If I'm telling you to trace it back, and if I'm saying you this is the same thing as calling that square constructor, let's have it at the side there. I think that'll be easier. So you could fully see it and just work through it. Let me try to even move this. Okay. Okay. Let me create the cube.
How'd you do that side by side?
Huh?
How'd you put it side by side like that?
If you just move it around, it does it for you automatically. Like if I move it around here, you see those rectangles popping up?
Oh.
Yeah. All right. Let's trace it. So now we forget the square. Actually, let me put the square here. Okay, I think this is a good little map. So execute square cube. First we trace square. Square, you create the new square, 5 by 5. Where's it going? Let's look at the blueprint. The only thing right now that's happening is the square is getting instantiated. It gets the length, gets the width, it locks that length here, locks that width here, and while it's at it, it does the area. Length times width, right? Length times width equals this dot area. So this is locked in, right? And then you could get area, and you get the full area. So now the cube, right? I'll let someone else do it. Just trace the cube. And don't worry about the depth. Like I said, don't worry about the depth. Just trace it for a second. Like I said, super
So
refers to this. Yeah. So
You
cube,
continue and say this dot depth.
forget about depth for now, because that'll confuse things. For now, I just want to see what.
So what are we
super-
trying to do?
I'm just telling you right now, as it is, forgetting depth. Right. This I'm only putting in now to fulfill this, right? Because right now, if I were to delete this, it's gonna throw me an error, right? So I'm just keeping this here. We'll go over it, but for now, let's say I leave it like this, right? And leave depth alone. What's happening right now? Just look at it over.
It's putting those values into the cube function,
Okay.
and you did a
Constructor.
super,
but keep
so
going. Yeah.
yeah. So the super, it enters it into the square function in the square class or square constructor.
Okay.
And then now you can get area of square if you wanted to.
Okay. As you're heading toward. Okay. So what would happen right now? Do you think? Well, let me see if one of you guys could spot what just happened here. What do you think would happen right now if I were to press hit enter and focus on the console here?
I think you
Because
would get 16.
huh?
Uh,
You would get 16, wouldn't you?
Tell me why.
yeah, he would get 16 because it's not doing anything with the depth.
Right.
Yeah.
And yeah, exactly.
Yeah, the get area method, or I guess what do you call it, constructor now, or if it's a method, it only needs the two, the length and width variables. It doesn't
Right.
need a width variable.
Right.
I mean, depth variable.
Right. Exactly. No, that's the right answer. Let's run it. Right? And let's see what just happened right there. Despite these being separate classes, did you guys notice that I used the get area and I didn't even define it here? Why is that?
Because it's just the extension of the square method.
Extension of the square.
Square class.
Exactly. It's an extension of the square, and basically it's just like Fa said earlier. Anytime you extend it, now pretty much all of this, unless there are things you could you could protect this, that you could privatize some of these variables so they don't get passed over. But don't worry about that for now. The main thing is, just from the idea of extending it, we don't need that get area method anymore, right? So what's the idea of? We're not repeating ourselves. Just small incremental steps like this end up making a big difference, but this is how you start appreciating this idea, right? And despite not only that, but just from passing over the length and the width, we're automatically creating an area. I mean, it's wrong technically, but that's only because we haven't considered depth yet, and there's a way to do that. Just from this alone, cube has a depth, and we didn't define any of this. We didn't define the length, despite having to need it. We didn't define the width, despite having to need it. And we didn't have to create another get area method, all from this extension concept, right? The idea is called inheritance, and it's one of the four major kind of themes of object-oriented programming. And this is the best way to learn it, like kind of hacking at it like this, because you could read the definitions all you want, but unless you internalize it, something like this with that, like real examples, it'll never make sense. All right. So we got the length and the width, but obviously, like we said, this is not the correct area of a cube. 4 times 4 is 16. 16 times 4 is 64, right? So it's supposed to print out 64. So what do you think we do?
Can you put a int volume under int depth?
Say again?
Can you make another variable called volume?
What do you mean where?
Like right next to integer depth above.
Well, we have the depth, right? Now we just need to find a
Above
way
that.
to. You can.
Oh.
I get what you're saying. Technically, you're right, but we already have a area here, right? This is accessible if you want. And to prove that to you, I'll do this.
You do this. This depth equals depth.
Say that one more time. You're very close.
This dot depth equals depth. Because you're
Like that?
yeah. Because now you put in the depth variable.
Okay, but let me ask you this. At this point, if I were to run it, would I get 64?
No.
Why?
No, because the area.
You do depth times area.
You're very close.
Yeah.
You're very close, Fa.
This dot area.
Yep, exactly. So just like this dot depth refer to this, and you see it says it belongs to a square, right? Because well, let's see. Let's do this first. We can't. Okay. What? Say that one more time. This dot area.
This dot area times depth. Can I do that?
So this is called a operator. It's like saying 4 times 2. You get what I'm saying? Like you're not doing anything. You're just saying 4 times 2. It's nonsensical.
Okay.
What's
So you
missing
do-
from
This dot area equals area times depth.
exactly?
No,
This look good?
can you take out the this on the right side?
Oh, you want me to check it? Like you want me to
No,
hover?
no, on the side. Right. To the right of that. Why does it have a this in the thing?
You could change it if you want.
No. You're not. I don't know. The second this you put,
Yeah.
why'd you put that there?
Well, let me see. Because ultimately, I am saying it's getting locked up here, right? Because otherwise, you know how we got the get area, right? Focus on this, get area. It is returning an area, but which area is it returning? This area right here, right? So ultimately, this has the ultimate lockup, right? Locked up variable because this doesn't contain anything called area. So even over here, remember that extending idea. It's being locked up over here, right? So this dot area, and you see all these areas are getting highlighted. This dot area referring to this, saying equals this dot area times depth. Because otherwise, what else would you put? You could put area, I think, actually, technically. But you could do is this what you wanted?
Yeah, I was asking why couldn't you do that?
You can, but sometimes it's usually better practice to always know what you're, because usually you see how we could have said like, so for instance, length refers to the parameter being passed, right? But that could easily been the length in the class, right? And it's usually conventional because to usually know that you're referring to the class variable and not the parameter variable, you use this to signify that. And since I'm modifying this, I want to keep referring to this. You get it? Yeah. Okay. So this was your answer, right? Am I good or should I do anything else?
Yeah, I think you're good.
All right.
You need another function. Oh,
No, go ahead. Because I want you to fully think of
Square
it.
had an area where you return the area.
Well,
We
you
already have that,
square
right?
class.
Because remember, we already used it. We proved it to ourselves that this is accessible, right? So why put another one? You get what I'm saying?
Oh, okay, good.
All right, let's run it. Exactly. There you go. Right? So just like you saw, remember, all of these things we didn't need. Length, width, and this area even. All these 3 variables and this, all we really did was pass in. Well, okay, now that you guys did that, now trace it for me one more time. So go through public cube and tell me what's happening.
So that constructor accepts the length, width, and depth.
Uh-huh.
Then you use the super short for like superimpose or something.
No, but it's saying to refer to whatever it's extending from, which is a square, right? So what's happening right here? It's taking the length and width, and what is it doing with it?
It takes this length and width.
Over here, right? The 4 and 4 takes it. And
Yeah.
does what?
And puts it into the length and width in the square class.
How do you know it's doing that?
Well, if you mean from the code?
Well, all I have so far, you told me, is the super idea, right? The length and width. But it has to. Where's the logic that's saying it's being stored in length and width? Because so far,
Well-
super length and width, this could end up not doing anything, right? But where's the logic saying that it's being stored in this length and width?
Well, it's extending the square class.
Right. Okay.
So, yeah, isn't that?
Well, yeah, like
It-
it's extending it,
it's
right?
extending
But the actual
the
logic
vessel.
of locking it up in there, it's right here, right? I was just hammering that point in, because anytime you think of super, just think of the constructor, because all it's saying is this exact thing is being called, and each of these lines are happening, right? So basically, super length and width, taking that 4 and 4, taking length and width, jumping right to the square. After that, it locks it up. This dot length equals length. This dot width equals width. And not only that, but it's also calculating that area, which is so far what? As
Wait,
of this.
hold on.
Yeah, go ahead.
So when you're doing public class cube extends square, is it extending the constructor or the class? Oh, I mean, I guess I just answered that myself, because in your squares class, you got the class that's is called square. You also got the constructor called square.
Yeah.
So that's a little confusing, because now is it extending the whole class, or is it just extending that constructor?
So all it's saying is the constructor just refers to, how we used it here, right? Square equals new square, right? All this is saying is how to behave when somebody starts using it. And the only thing, I get what you're saying, because you don't see it happening, but just like we used it in the main class, this cube here, right? All it's saying when you use super here, it's basically the same exact, well, in this case, it was a square. So just like we use square equals new square here, when the cube is calling the class, and this is because this class interaction, right? Because the cube is using it in its constructor, it's saying super is just a shorthand form of saying, hey, the class I'm extending from, I want to utilize its constructor, right?
Okay, I got it. But
Yeah.
what just confused me is because you got the class and the constructor the same name.
Yeah, that's just the idea of it. So that's only because I could have left it blank, like this could have not existed, right? But because I want this added functionality of being able to pass in the numbers in without my having to do anything else, like how we did before, we had that extra method called set dimensions, right? To avoid that whole hassle of having extra methods to do that simple functionality, this is what you do. Just so in one line, I can utilize. Think about what just happened in one line. Just from creating instantiating this class called square, passing the what just happened? I with that alone, and because of this constructor here, I was able to lock in a length, a width, and calculate area all in the same one line. You get what I'm saying?
Yeah,
Yeah. So
I got it. It's just a name that's
yeah.
confusing.
It's
Can
just
you
saying.
call it public square 1? Like, it would then be like, or call it something else completely different. It wouldn't change anything, right?
What do you mean?
You would just like where in your constructor, like if you're saying you call it public square,
Mm-hmm.
you call it something else, public
You
square.
can, and I'm glad. Yeah.
dimensions.
Yeah, I'm glad you brought that up, because you could have multiple constructors. So what I could have done is this. And so far you see there's no errors. Could have done this.
Like you have name, okay.
Right. I could have multiple constructors, right? And I could have done something like this. So you see, this is not invalidated because this still exists, right? So the only rule is you could have multiple constructors, but make sure you define why you wanted to make a difference. So at the very least, you need to have different types of parameters. You could pass a string here if you want, You could pass anything here if you want, right?
But my question is, can't you have? Do you want the constructor to have the same name as the class itself?
Yeah, yeah. That's the only way to make it known that it's a, you know, it's a constructor, and then it could be utilized like this. Otherwise, you would have to do like square dot, like any other kind of function. You get what I'm saying? But to you use it in this fashion in line 30 right here, you need to have the same name exact. So to prove that to you, there you go. It's automatically an error.
Okay,
So
okay.
it
I
becomes
see.
like any other method.
So then, is that get area? Is that considered a no? That's considered a method, not a
Right,
constructor.
right, exactly.
Gotcha.
And that's how you separate the two. They look like, that's what I'm saying. They look like the same exact thing, but those little differences make a big deal at the end, right? Yeah. So just like you guys said, but how about if I did this? So we did say depth is a part of cube, right? So what if we wanted to get depth, right? And it's an integer. And what if we said, right? So, you know, keep a close eye on this, right? So what if so get depth is just another function I created saying return this. And it's like, you know, I know you mentioned earlier you were, you know, kind of confused about this, but you know, it's sometimes this stylistic choice. I only I'm saying return depth just because I know it doesn't exist in square and it doesn't really matter. But I could have done this. See? Same thing. Not a huge difference. So what if I wanted to do this? What would I get?
Dot get depth. It would run the get depth, return depth.
That would give me the depth.
Which is
well, you didn't. You have to first put this depth equals. Wait.
You're close.
Yeah, so you would need to do in the what is that? The cube class. You would need to type in this dot depth equals
Depth.
this area
Exactly.
depth.
No, exactly. Right. Because let's try to run it just for argument's sake. You get a 0 because integers automatically initialize at 0, right? Despite having this 4 passed in, we never locked it up. So you got to be very careful, right? So what happened here, yeah, we did utilize depth to get that area before, but we basically just discarded it after line 9 over here, right? We used it, we got the area, and then but we forgot to lock it up. So you got to be kind of careful. Right? Okay, so we got that idea. And just to make sure, now we do get the depth of 4. So let me remove this. All right, so already you're starting to see these relations form, right? And now if you want to compare the two, let's take out depth, because who really needs depth on a cube? You care about the area, right? Compare square and cube. We would have pretty much, just imagine for a second, like what we would have had to have done if we didn't use this extension, right? I know it doesn't seem like much, but even on the offset, even from the naked eye, you can see you cut that by half, and this is what you get, right? You're already saving a half amount of space, which is a half amount of things to read and concentrate on, right? Otherwise, imagine if it were imagine if we didn't extend it. What would we have had in the cube class? We added the length, the width, the area, all we had defined in square. Length, width, area on top of depth. And not only that, the get area method. All shapes are the same in that when you return when you return the area, yeah, they have different means of doing it. With the square, it's just length times width. With the cube, is length times width times depth. But we calculated that all in a way that's kind of much more efficient, right? The only thing we really specified outside of calling the constructor over here is the depth, right? That's the only thing we focused on, really, if you think about it. All we did is took the area, right, and multiplied by depth. All right. Okay. So that was a good exercise. But now let's get to something a little more complicated. right, let me take out the square. We're not gonna need square anymore. We're not gonna need cube anymore. Well, no, we'll need the cube, and you'll see why. But we definitely won't need the square. So the reason this took me a while to, I took an extra day, is because you could go over definitions all you want, and you might even understand the exercises to an extent you see online, but you'll never see the bigger picture. And the reason you won't see the bigger picture is the only reason stuff like this ends up being useful is when your code base is large enough where you need it. Otherwise, what I mean by that is, you could have had technically you could do it, technically you could create any app in the world. And this is a really, really extreme example, right? Technically you could have made, technically you could do it in a way where you could make the most bloated type of function in the world, and it could, technically you could make an app out of it off just one function, right? And that's why I say, ordering is so important, structure is so important. You could do it, but it's impossible, so it shouldn't even be a thought, right? You could have a million different functions literally, and each of them could have their own little thing they do, right? But you just simply can't do it that way, right? It's not possible, like humanly possible. So that's why these you already saw with that shapes example, right? We could have had 100 different squares, you could have 100 different variable names, but it just wouldn't be efficient, right? And so the way I thought of it is to make a really tangible type of example you could use, right? And I was thinking of doing it in a way where, imagine you're a farmer, right? And all of this is literal, I'm not joking around. So imagine you're a farmer and you have, and let me even write it down for the video, because all of it is going to come into actual utility, the whole farmer example, right? So I'll say farmer example, but it's going to be simple. It's going to be like deviously simple. I'll probably just summarize it in probably 2 sentences. So suppose you're a farmer and you have cattle, you have cattle and like crop, and you're trying to transport, and basically what you want to do is you have boxes, and already you should kind of the reason why the cube thing comes in handy here, but you have boxes, like think of them as like transportation boxes. Let me put this in actual English. As a farmer, you have cattle and crop. You want to transfer them in boxes, and that's it. That's literally it. Like that's the whole example. As a farmer, you have cattle and crop, and you want to transfer them in boxes. The cattle could be cow, sheep, chicken. All will define as classes, by the way. And you have crop, you have corn and everything, right? And you want to transfer them in boxes. But the thing is, obviously the boxes, you can't have an infinite amount of box sizes, right? So you're restricted by that. So another restriction is that restriction is boxes come in small, medium, large shapes, right? And obviously the cattle come in different shapes. Crops, let's not worry about that. So, a cow is going to be bigger than a sheep, which is going to be bigger than a chicken. So another restriction is animal sizes, right? And all I want to do is, as abstract as this seems right now, I want to do it in a way where, let me see, I did write it all down. Ultimately, I want to get this something like this. So, despite you guys having no clue as to what I'm trying to get at here, ultimately, right here, I'm in the main method, right? And you could have the basic idea just from this alone, just because I abstracted it enough where it's like understandable, right? I have a container. I have a small container, a medium container. I decided to add 2 sheeps, right, in the medium container, right? And then I have a large container. So 3 different containers. So small and large, I didn't add anything. And the list is, we went over the list before, and the list stores containers, right? And let's see what I did. And I just added the different containers into the list. And then at the end, I just iterated over all the containers. I only put the list here so I could iterate over it, right? You guys are used to the array list. I iterated over it. And I just wanted to get the size of thing. I wanted to get the size of each container, right? So it would be right here, 0 to 0. And mind you, all of these have restrictions. So what I mean by this is really quickly. So let me just run it. So basically the way I have it programmed is, hang on. Okay. Let me just take this out. Oh. I gotta take this out too. All right. So what happened here is I got my medium container there, right? And if I go into my medium container, I have specific dimensions for it. I think I made it 3 by 3 by 3. 3 times 3 is 9, 9 times 3 is 27, right? So if I go back to it, and I know this is confusing, don't worry. So the medium container is of size 27, square area, right? And the sheep, for argument's sake, I said sheeps were 20, just an arbitrary unit, 20, right? So
Yeah, am I supposed to be able to follow along with
no,
this,
not at all, not at all. Don't worry. This is going to be a very high level example of what ultimately I want you guys to do. So I added the sheep into the container, and what happened is I added it first, it didn't say anything. But when I added the second time, because it passed that 27 mark, it said not enough space, right? And ultimately it's saying I was only able to add 1 into the medium container. But let me not go off because that'll just confuse you further. So ultimately I just want to create a farm example. So in order to create a farm, I want my containers. What do you think? Hang on. What do you think? Let's call it tools, right? Already I'm just using packages. And just like a farmer has his cattle, he's supposed to also have his tools. Let's assume a container is a tool. All right. So what does a container remind you of? Taking into consideration all the shapes we just used.
Cube.
Cube, right?
Cube.
Yeah, exactly. It's rectangular, or it's cubic. So let's extend it. And right now, so far, it's a small container. Just like
So you can something that also has an extension in it?
Yeah, you can. Right? It's like imagine a tree, right? And just like we had to get an import here and a constructor, right? Okay. The thing is, so let me tab that up. So this got auto-generated, but like I said before, let me bring up cube. So there's always that example here. Okay, and I'll always keep the execute over here because we'll always be using that. Okay. All right. Okay. So far, small container. I'm assuming small, but that'll all make sense in a bit. I got the small container, extends cube right here. So like we said before, since the cube is already factored in depth, the length, the width, the depth, right? It's all there, right? But the problem is, the way it's shaped out right here, right? I could use it now, technically. And don't get nervous about these errors. They always pop up because of these packages, but all it is just a package issue. So I move my mouse over, import small container. It's good to go technically, right? And just like before, I can get area, right? The thing is, just like I mentioned before, containers don't have infinite types of sizes, right? You're a farmer. You have let's even just put it out there. I only got my small container. And remember the container example. I'm going to use them for animals. I'm going to use them for plants and everything, right? To eventually be able to ship them. I got the small container. I got the medium container. I got the large container for stuff like cows because they won't fit the medium and small. Let's start with the let's start with the small container. The problem here is, the thing with classes is you want to start adding structure to your code. And if I'm just letting you create any type of container, technically with these constructors I am, right? I could let the end user, which could be you, Fa, it could be any of us, right? We could create the end code right here. But I don't want to use that way. How do you guys think I could, if I assume in this left pane of the screen, assume I'm the end user. This is not what I want, because this is saying it's basically letting you create any type of container size I want. How do you think I could avoid the end user from doing it? Because like we said, a container should have specific area. Should be like something like 25, 50, or 70. I want that. I can't have any other type of cube.
Well, first, you make it private, right? But
no, don't think of anything like that. Think of how this. Think of it. Just look at this for a second. Without adding anything onto it, what can I do to at least stop the user from being able to make it any shape you want? Ish, you should pitch in too.
Put it in that that class, the small container class. Put the dimensions in there.
What do you mean?
Like you're saying, you're creating a object, small container.
Right. Let's say small container, by definition, since it's small, should have. Let me put it after this farmer example. Let me just put the things out right now. Small container should be 2 times 2, 4, 8, right? Arbitrary unit. Medium container. 27, 3 times 3 times 3. Large container, 64, 4 times 4 times 4. Right? How do I guarantee that a small container, despite it being instantiated here, always has 8? I should ask it like that.
You would have to put something in the small container class that.
What? Remember, a specific
like
value.
A check to see what the size is adequate.
I can. But let me ask you this. If I'm asking for this 8, do I need to ask the user?
Can't be any other number?
What do you mean?
Like it has to be 8, a small
right,
container
exactly.
has to be 8.
It has to be 8.
So then you just wouldn't accept any parameters.
Exactly.
Right?
Exactly. Right? So how do I do that?
Well, you call super. I mean, do you need a constructor then?
Yeah, but it won't be obvious now. But go on with your line of thought.
Well, You just for a small container, you just hard code 8
Exactly.
if it can't be anything else.
Right? Well, hard code. Well, not hard code 8. Hard code what? Remember, this is still a cube at the end.
Oh,
Code area. For the length, width, depth.
So what should I
you
pass
just
in?
send in super. You just send 222, right?
Exactly. Right? Everything I could have done length, width, depth, but like I said, I want the specific number, so I put in this, which gets over here because it's a cube, and does all the area business like we calculated before.
So then, can you delete those parameters or
Exactly.
what?
We don't need it, right?
Yeah.
Yeah. So what would I get here? Right?
8.
Oh, that's all I'm asking, right? So let's process that for a second. I know that's like a kind of a jump logically. We're starting to delete stuff now where we weren't used to before. But remember, why did I extend from a cube still? Because it still has that cubic logic, right? Ultimately it is a container, which is a cube. And I still need that get area function, which we calculated right here. This times area times depth. I need all that, right? The only difference is because I'm defining for my farmer example, for this farm example, a small container must be of size 8. I don't want the user to have this ability to pass in any parameter he wants because first of all, I don't need it, right? If I want my container to be of size 8, I don't want him to be able to pass any other parameter he wants. I still want that get area function, but I still want it to be a very specific dimension, right? Otherwise, I mean, just think of it in a logical sense. Like you have a finite amount of tools in the real world. And this farmer in our example only has a large container, medium container, small container. If we were to be able to let the user pass in any kind of energy he wants, he could make an infinite number of containers, right? And a small container, quote unquote, would make sense, right? Does that make sense, or should I repeat that? Fa, what do you think? There's more to it, or let me know if I could keep going. Okay, let me ask you it like this. So taking that logic, what do I do for medium and large container?
You do the same thing.
Which is what?
Um,
Well, hang on. Before you continue, let me just X this out.
you would just extend from cube,
Okay.
and then you would make a constructor with large container.
Well, literally, I want you to spell it out for me just so I know what you're saying. So go ahead.
Large container, and we're not gonna put parameters because we don't want them to manipulate how
The
big it is
dimensions,
or
right?
whatever.
Because we want a
So-
specific dimension, which is 64, right?
Yeah, so we're just gonna use super, and then we're gonna put 444 in it, and
Yeah, that's it. I think we're good. Let me see. What else we're missing? Oh, import. Yeah, we're good. 444, and same thing. To make a long story short. Oh, 333.
Extend.
Oh yeah, you're right. Okay. All right, so we get the benefits of the cube. Let me import it. We get the benefit of the get area method, but you see how he shortened it so far. So just as a constant reminder of how this stuff works. So let me pull up square again. So I guess you just go from right to left, right? You just keep seeing this. Well, don't pay attention to this because it's with the executing class, but look at how it keeps shortening, right? You got your square, which has all the logic, right? And then that divides by half. And now this divides by half, right? And despite this having all the functionality of a cube and hence a square, you could just keep extending it with with smaller and smaller amount of code and logic, right? This is how you avoid mistakes in the future and makes your code more like beautiful in a sense. So let me X that out. So we got our containers now. Okay. So now we got our containers, and let me just prove it. Let's make small, medium. Yeah, let's pick a random one. Get the area, which should be 27, right? Okay. That's fine. Let's see how much more we could even enhance it. So another functionality of these classes is you want even more, like you want even more specifications, right? 444 could mean, still technically 444 could mean anything, right? You want to be even more specific. You want to revert this to as much English as possible. So here's another, a little tool. And like you'll see, you don't need to use any of it, right? These are technically these are all alternatives, right? But let me ask. I mean, let me just do it first and kind of get you guys almost opinions of what you think of it. Let's just do this for now. Right? So I got my small container, and it is 2 by 2 by 2, right? But the thing is, let's say I got 100 lines of code here, right? All using a variety of containers and all types of logic, right? And I'm knee deep into the code, right? But suddenly, and this is you could even think of it as a real example. Let's say dimensions change, like the farmer gets a different brand of containers that are slightly larger than the originals. Technically he can go back into the small container and change the logic, and it would reflect here, right? But the thing is, you're so much into your code, you're not completely sure what it does. And here it's not going to be obvious, right? It extends a cube 2 by 2 by 2. It's very obvious, right? But you want to be more specific because you never know, and you always want to be as verbose as you can. So what I just did here, right, is just I created these things called constants. And just like how you use the utils method, right? And these public static int, the idea of that is you can refer to, kind of more verbiage. So instead of saying what I mean by that, and there's a reason why I put all these terms here, and I don't expect you to know this right away at all. Don't worry about that. But I do kind of want you to get the point of it. Right? So it's not a huge change, right? Technically, this still all refers to a number. But if you want to, kind of think of it in a way, you have all these constants here, and I'm going to add the rest. But you got all these the small constants for the width, height, and depth, and you could add the same thing for the others. So medium. Medium. All right, so those are 2. This is going to be 3. Let's make that 4. It's not a major change, but from now on you always have this list of constants. So think of constants as, the reason I put them as final, and I didn't include them in the rest. Let's just leave it for now. So the reason I put final here is because sometimes numbers change as you code, and this is just like, think of it as a repository that you always refer to, right? So large height, large width, large depth. And just to wrap it up. Medium depth. Yeah, so that was more of an aside, but it's just small things that like that kind of add up. But let's just move on to the animals now. So we got the animals, right? Give me a second. So let's create a separate package for them. And then we could just name it off. You got your cow, right? You got your, and if you guys have any questions, I know this is kind of mundane right now, but it adds up to it, and you'll see the difference after I type it all out. But if anything doesn't make sense, just call it out now. Like why I'm choosing these classes and not something else or anything. So you got your cow, sheep, chicken, corn. Let's just assume that's just the livestock and the crop he has in his possession, right? And what's the main thing of these livestock we care about? So we have our containers, right? We got the large, medium, and small. What's the main quality of the the livestock we care about?
Size.
Right. So let's start with a small example, right? So let's say arbitrary, right? 5. Now let's even put it at the rest. So cow's gonna be big, right? So let's put it as a 30. A little smaller, so let's put 15. And corn is a 2. Okay. So ultimately, so let's focus on this. So we have these 3 containers out right now, right? So for now, let's just focus on the medium container, right? So this is what it looks like now. And as you remember so far, technically there's no difference between it and the cube, right? We did impose these constants to it, the medium height, width, and depth. But if we want to start storing, let me take everything off. Save selected. So let's just focus on that. I'll put that on the side. And because we did instantiate the chicken, we'll stick to chicken for now. We can use the chicken. Okay. Import it. just think of the container and think of the chicken, right? We did give the chicken of size 5, and what do we say the medium container? How big was it? Let's just look really quickly.
27.
27, right? And just for simplicity's sake, right? Anytime you add it, what are you really doing?
Taking away the size.
Like
that size.
let's say you're storing a chicken into a medium container. What are you doing?
You're taking away the available space.
Right. So in mathematical terms, what is that?
So 27 minus whatever the size of the chicken was.
Which was 5, right? Okay. So the problem is, how do you start representing that? Okay. What do you think? You take a wild guess. Like, I mean, or not even a wild guess, just slowly kind of formulate your thoughts, right? This is a class just like any other class that has its own methods, right? So obviously, you want to start with methods, right? So just like how you use a list, remember how you use list. You added stuff to it, right? And then, depending on what you added, you passed it in, right? So how do you begin making medium container? There's a reason I chose container, because you guys were good with lists, so that's why containers are very similar, except logically speaking, a list you could add an infinite amount of stuff. A medium container, we already imposed that restriction of it, which was 27, right? So how do you at least begin to populate this to give it some kind of form?
So you would create a list and add. You would create a list that adds.
Yeah, you're on the right track, by the way. So don't.
Or maybe a hash map. I don't know, that way.
No. Let's stick with lists. You're in the right track with lists. So, what do you mean?
So you create a list and then.
So at the very least, you want something like this, because for all you know, a list has that functionality where you could at least add stuff, right?
You make a list and then you add whatever number of chickens, and then you subtract it from the size of the list or something?
Yeah, no, that's the very basic idea of it, and you're on the right track. It's just, how do we start formulating that, right? So list, you guys know, it starts tracking stuff, like it starts adding into it, and before you were used to doing like this. So the way I should say it is, if you're used to, and take note of the fact that we're putting the list specifically in the medium container, right? So since the list is in the container, remember, before we use strings, you could create a list like that, or we use integers, you could create a list like that. But what do you think we're adding to the list now?
Integer?
No, not integer.
Oh, you mean like
A string?
We're adding chicken.
Right, exactly. Chicken, at this point, with how we define it, chicken is no different from an integer in that it's just a class. You could use chickens. There's nothing stopping you. All right, let me import that.
So you have to put in okay.
Okay. So let's progress with this slowly, because this is kind of, this is kind of hard to deal with at first. So we got the medium container, and we didn't instantiate it just yet. Remember, how do we complete this?
List. Well, you have to something equals new list.
Yeah, a new array list, right? But the thing is, since this is not inside of a method body, you can't do this, right? You'll get an error. No, actually you can do it. What am I talking about? No, you're right. So you can do it this way, but I mean, that kind of ruined it because I forgot you could do it that way. But the basic convention, as convention dictates, you're supposed to do it like this. Just because, think of it as you could have a bunch of dormant variables, right? Or whatever. But in the constructor is when you decide how to actually end up using it. So what I mean by that is you usually leave it in the constructor. So far so good, right? That means that right when I create this medium container, right? This list is instantiated. This is ready to use, right? So now what?
Now you gotta begin adding to that list from the main class.
No.
the
Well, okay, no, no,
execute
no.
class.
Let's go off that. What do you mean by adding to it?
Well, every time you're adding an animal
How do I add the animal?
by making a new object
Of what?
in the execute class.
Okay. No, just tell me exactly what you want. So far we got this, the containers, and we got the chicken.
So you did chicken, you created a new chicken object, so that somehow that should be added to.
Somehow, that's the important part. Somehow that should be added in the medium container, right?
Yeah.
Like, exactly. Keep going from there. What do you do? Do you do anything to the medium container class?
Well, obviously you have to add it, so you have to call upon it somehow.
How do you do it?
Yeah, I don't know that part.
Well,
I guess if you did add, well,
no, you're on the right track. So how many methods of list as a class, an array list, how many methods can you think of?
Well, if you press dot, you should say them all. Right?
Yeah.
Or
It says them all. It has list.get, all these, right? But the way I'm telling you is between this array list and this medium container, there's no difference in that. Just like the version developers populated this with methods, right? The same thing you can do with this medium container. So how do you do it? So you got the medium container, but you can't do anything with it. What do you think you do?
Well, you gotta make a object. No, you gotta make a method.
Exactly.
Medium container method.
Exactly. So what do you want to call the method?
Can you call it the same thing? Oh no, you gotta call something else.
You could do the exact same. No, I'm glad you said that. And actually, we should call it the same.
Wouldn't
method.
that then be a constructor and not a method?
What do you mean? We could do like this. It doesn't have. So you have the constructor here, right? But there's nothing stopping you from creating multiple other methods, right?
Oh, gotcha. Okay.
So go ahead. So
Yeah,
that
so
was your hint.
Call
So
it
you-
public medium container.
What? So far you got it right. We're creating a different method.
Can you call it the same name?
No, you could just like you know how list has a get method, an add method.
Okay.
Size method.
Public void list integer or list chicken.
Well, you're just adding a chicken, right? So why don't you say add, right? I didn't fill it in yet, but clearly I want something like this. What I'm getting at is
Oh, that's what you're calling. Okay.
right. So it's showing. I didn't do anything to it, but at the very least, it's showing a method that I could use with this medium container, right?
Got it. Okay.
Okay. The question is. The question is, what do you populate this with? So ultimately, I want to do something like this, right? So what kind of parameter? What kind of parameter is it expecting?
It's expecting a string.
Why?
Well,
Actually, chicken is an integer, no?
No, chicken is a chicken. Chicken is a class.
so it's expecting a class.
Yeah.
So how do you? Is that the same?
Yep. So just call it. Most likely, just go with your instincts because it's probably true.
So over there, public void add, and the parentheses you would put. What?
Say again?
Chicken is
Yeah.
parameter.
Yeah, chicken.
Oh, chicken. Okay.
Right. So far, so good. Yeah, I know this is kind of kind of makes you uneasy because you're usually expected, passing in strings and integers. But just like you passed just like you passed a string, there's no difference. I'm trying to hammer that point in. Just like a string is its own class, a chicken is its own class because we defined it here, right? Okay.
I see. Okay.
Yeah. So, but the whole idea of adding, though, that's not something That's not like the idea of adding the list. Adding a thing to an object. The actual backend functionality of that is not something I know how to do, right? So what do I refer to now? In that, how do I start adding the chickens?
Chicken. So you do chicken.add.
What were you gonna say?
No.
No, say it.
I'm not sure actually. You can't do chicken.add because that's what you're trying to make right now.
Right. And
Um,
chicken, there's nothing inside chicken. So if you say chicken.add, the only thing in there is size.
Strange.
What else do you see in here outside of the constructor?
Array list.
Yeah.
Add to the list.
Yeah. Don't psych yourself out.
Oh, add to the list. Okay.
So how do you do that?
List.add.
Yeah.
They could do chicken.
Yeah,
No, wait.
that's it. Look, list.add, and it already fills it in for you because it's saying you expecting a chicken, so it's saying, hey, you're gonna add your chicken, right?
Okay.
And this did it automatically, but look, list.add chicken, right? So the chicken you pass here, it's gonna add into it, right? Does that make sense? Or
Yeah, I get what's happening. It's just this is something that's going to require practice.
no,
to
no,
really get
definitely, and that's why I'm not giving any homework because ultimately I just want you guys to, review it. So first over, no, I'll push it. I'll push what we have so far, but we'll add into this. This is gonna take at least another week, but I'll push this in, and I just want you don't even touch it. Don't do anything to it. I'll push it in a separate branch, and all I want you to do is go through square, cube, containers, and see how it all fits together. But there's a problem with just adding to the list. What is it? We did mention it before. What is it that we said is specific to containers?
the size.
Size, yeah. Like we said, it's limited by size of whatever it is, 27, right? So,
Yeah.
but we're adding to it, right? And we want this add function to be smart enough to halt the adding process. You get what I'm saying? So like, say I did this, medium.add. Let's say there's a few chickens. So chicken 1, chicken 2, right? And you added chicken 1, you added chicken 2, right? I want this to be smart, this add method to be smart enough, because remember, a list has the very same add method, except if I were to keep adding to the list with chickens, it's not going to make me stop. I could keep doing it infinitely, right? That's the point of a whole list. But we're not creating a list. It's already been created for us. We're creating a container, a medium container specifically, right? So how do we make this add method smart enough to stop the addition of chickens until we hit that 27 cap? Think about
Meet
that.
the size of the list. So if the size, let's say, is like 5,
Mm-hmm.
like if the size of the list is like 5, you add 1 to that 5 and then multiply it by chicken's weight or whatever that is, the 5.
So, okay, a bunch of things just happened. Let me just bring that chicken out. Let me take this container. No, let me take that out. Okay, like you said, the chicken has a size of 5, right? What else did you say?
You would need to get the size
Of
of the list making.
Is it the list that we need to get the size of? Remember, for a list, you could just keep adding to it, right? What is it that contains that bottleneck?
Medium container.
Right. And
the size
okay,
of the
how I
container?
should hang on. Let me say this. This medium container, as it's instantiated at this moment in time, what's the area?
27.
How do we know that?
That's
Well, let me click it, right? And like we said, if we go back to this, medium weight, all this multiplied together is, as you said, 27, right? So we did get that part. So this part right here, it creates a background area of 27. You got that right? The problem is how do we use it?
Isn't the chicken adding to that?
That's the idea of it, right? So how do we grab this size? So okay, well, let's do this. Usually when you have a field variable like this, like size of 5, right? You still want to create the method because just for just to keep this protected so your code doesn't end up changing it. You have a getter, right? So what I'm saying is, if I were to do this now, and remember this because this is going to come in handy. Let me comment this out for a second. So we got the 5, right? So remember, we got the 5 now. But the problem is, this is not useful in the main method, the execute method. This is when we want it to start working. What I want done is after it adds here, right? I want this add method to be smart enough such that it caps me off after I hit that the size of the container. So how do I do that? So over here, how do I make this smart enough to do all that? So let me open up. What does this extend from?
Cube.
Okay. All right. So it extends from cube. What do you see in cube?
Length, width, depth.
Length, width, depth, which, remember, since it's a medium container, what is the area?
Length times width times depth.
No, I know, but the area is 27, right? Since it's a medium container, right? Just look at it over here. Medium container right here is 27. Okay. Any type of logic you could think of. Let's comment this out for a second. Don't add it just yet. Any type of logic you could think of that says that anytime you add a chicken, you want to take away from that area. So from here, how do I reference that? At least let's say, how do you reference that area in cube? What was that way we said?
Get area?
Very close. Well, yeah, you could do that.
Area?
You could do this, right? But what's an even easier way?
Area?
Well, this dot area, right?
This dot area, okay.
Remember, cube extends from square. Okay? So this is 27 for now, and we didn't complete it. That's why you're seeing the error. How do we manipulate this area which belongs to the cube, which is 27? Such that if you were to add that chicken here, I know it's a lot of kind of wrapping your head around. Medium, referring to this medium container right here. I know it's kind of cut off. Let me try to extend it. That's it. Medium, you add the chicken. Chicken has a size of 5, right? So such that anytime you add that chicken, you want to utilize that 5 and subtract it from that area. How do you do it?
So you do this area equals this area, this dot area minus something.
You're very close.
Minus.
Say again?
Minus
Size.
size.
Well,
Chicken
tell me specifically.
Size.
Yeah, you're pretty much there. I just want a concrete answer.
Chicken one.
No, you guys are very, very close. So yeah, chicken one is the one being passed, but look at the chicken class. What do you see in it that hints at?
Size. Which one size? Chicken.
5.
Yeah, it is 5, but how do you get that 5?
Oh, it's a size.
How about this?
Chicken dot size.
Chicken dot get size, right? Because you saw me use it here. That's the only reason I kept asking.
Oh.
I didn't use it there. But yeah, like so. Say again?
You said chicken dot get size, right?
Right, because why? Chicken has a method that you could use, right? Just because you're not in a kind of a class called because you're not in that main method doesn't mean you can't use that chicken dot get size, right? Because you're referencing that chicken, right?
Oh, right. Okay, I got you. Chicken dot get size.
Okay. But just think of that logic for a second more, and then after we get the add method, we'll end it here because I'm realizing there's a lot to take in. So I'll push it, but before that, let's think of the logic for a second. Suppose that box is of size 27, right? And let's say you add a bunch of chickens, right? At a point, you don't want to add to that. You don't want to add to that list, right? Because we haven't added to the list just yet. If it's 0, or if you add something and it ends up being less. So let's say you had a space of 1 left or a space of 2 left in the box, right? And let's say you added a chicken which is of size 5. Obviously, if you add that chicken, it's going to be a negative answer, which doesn't make sense. How do you ensure that doesn't happen? Just think of that logic for a second.
A for loop?
No.
Why
a for loop?
If else?
Yeah, if. There you go. So, but how do you use it? If
medium container.
Well, you're in the medium container.
Oh, you're in the medium container. If
Okay, let's do this. So let's instead of changing this right away, this dot area, let's say you call it a temp size, and that we're not going to temporary size. I mean, right? This is for the sake of the logic. So let's say temporary size is this. So nothing has changed just yet. We're creating a temporary integer called temp size. So just walk it through. You got an area of the medium container. You subtract from the chicken dot get size, which the good way to do this is take yourself through a few examples. This could be -2 right now, right? Technically. I mean, yeah, we did add it, but not just yet. We didn't cap it off just yet. So temp size, go on.
So if temp size is less than 20, size 27, right? Yeah, 27. But I guess instead of that, you could just say what the area of the medium container. However you call that.
Right, because this dot area refers to the area of the medium container. So you got a 27. You're doing this so far right. You're adding it. You got the area of the medium container. You're taking the chicken size of it. You're putting that in temp size. So let's take it through. Medium container right now has a size of 27. And let's say you just added 1 chicken. Right? If chicken is of size 5, what does this equation, what is temp size equal to right now?
Gotcha. This area -5, so 27 minus 22.
Right.
Temp size is 22.
Okay.
So if temp size is greater than 5, greater than or equal to 5.
But this is 22.
You can add a chicken.
Okay, how about this logic? Say you keep adding the chicken, right? And as long as it's greater than 0, you add it to the list, right? Because otherwise it would just keep adding to the list. You get what I'm saying? As long as it's greater than equal to 0.
Greater than 0, I gotcha.
Right.
Okay, I get what you're saying.
Yeah,
okay.
yeah.
So yeah, if temp size is greater than 0, or greater than equal to, or greater than 0.
Or equal to 0, right? Because technically, if you subtract
Well,
it,
if it's
if it's equal to 0, it just means up you already took up all the space, right? So far you're good. Go on.
can add another chicken. So how?
Well, so far we didn't utilize the list yet, right? So if temp size is greater than or equal to 0 for now, that means you could add it to the list, right? Because it passes that check. Otherwise, we would have just, you get what I'm saying?
So you do a list dot add,
Exactly.
or yeah, there you go.
Well, and let's just say else, not enough space.
Okay.
And it'll make a lot more sense now once we see it in action, you'll see. Right? Not enough space. Not only that, we're leaving that logic off such that it doesn't even touch this list anymore. So let's see what it looks like. So we said chicken size is 5. And we said this is, just to make sure one more time, 3 times 3 times 3 is 27. So that's, to cap that, you would need what? 6?
5 chickens.
6, right?
Or 6 chickens. Too much, yeah.
So let's do that. So if I did this, let's even take this out now. 1, 2, 3, 4, 5. What's gonna happen if I just print right? If I just ran this right now?
It would add it to the list.
Right. But are you expecting anything in the console?
Do you have a system that out? I don't think so. No.
Exactly. So we're not expecting anything, right? So what do you guys think? Fa ish.
No, I don't think anything. I don't think it would say anything.
Exactly.
Hold up.
No, I already read it. It won't see anything, right? But let's see what happens when we do it now.
Then I'll say not enough space.
Oh wait, we did forget something. But I'll let you you're very close to finishing this up, but there's one thing we missed. So again, it's not saying anything. Why? I'll say as a hint, it's one more string of logic you forgot.
Never mind.
You're very close. It's literally one line. Ish, you think you know?
I'm not sure.
Okay. No, this is tricky, but this is all putting you all guys on the same, level. So
Static void? I don't know.
No, it's nothing static. So just look at, it's going to be in this add function, right? We're missing one thing. And you guys I'm pretty sure, I think it was Fad that pointed out before. It's the same exact logic. It's in the add function. We're adding the chickens one by one, right? Well, we're adding into the list.
Size?
What about size?
Size of the list or whatever.
Not the size of...
Size of the container?
Okay. No, you're on the right track.
You got actually.
Size is greater than 0. List that a chicken. This area. Minus get chickens.
I think this is going to be your aha moment if you guys get this part.
Well, what are those things you commented out?
Yeah. You're right. Which one?
That chicken. This dot area goes this area. Oh, this dot area it goes this dot area minus chicken.
Yeah.
Wait, no.
But why? Why is it that? And where should I put it?
After the list dot add chicken.
Yep. Why? How did you get that?
All right. So if temp size is greater than, so if we have space in the container, you add the chicken, then you get the new area. Well,
Right,
yeah, you
because
got
in
the
here the only
of the
thing you
area.
did was a function. You didn't actually change this area, right? You get it? So the area of this of the container, you did subtract the get chicken size, and it is a temp size, right? But you're not ever changing this size from 27, the area, right? This dot area. With this function, this dot area, which is 27, right? Remember, it's a medium container extending from a cube, which we locked up in the length, width, and depth. The area in that square is 27, right? You're never actually subtracting from that 20. You subtracting from it once, but you're not subtracting it directly. You're saying this dot area minus. So it's saying like, yeah, you subtracting from it, right? But you're never changing that value, right? You
Right.
guys get it?
You're only adding to the temp size.
Right, for like temporarily to use it for this. You can use that one round, but at the very next time when you do it, it's back at, the original, right? So let's run it. There you go. You guys get what just happened?
Yep. Actually, yeah, I got it. So what happens? Can you run it again by only having 5 chickens?
Yeah. So now we're expecting nothing, right? Because you added it, and since this comes out to 25, right, the total size, and the actual size of the meeting container is 27, you're left with 2 remaining, right? 27 minus 25. But since this is gonna reduce it to -3, right? As in it's gonna fail this test. It's not greater than or equal to 0 anymore, it's -3. You hit this. And that's it. Fa-ish, you guys get that part, or what do you think?
Yeah, I got it.
Yeah. Fa?
I think I got it.
Yeah. No, I think if you review it, you guys will be good. So let's end it here because this was a lot to digest. I get it. This is the hardest topic for a reason. So I'm gonna end the video here, and I'll push it to a branch called farm, just farm, and we're gonna add on to it next week as well. But just go over it like this. The exact way to go over it is start with the most simplest class, which is well, it's not gonna be simple anymore. You're gonna have the medium container and just trace through it. Use a command to click and just go through the logic. So you got the small container, you just command click through everything. So you got the.
So I get the logic, but it's like, how do you remember all this?
It's a lot,
Do-
right? So just think of it. Just start very simple, right? You guys remember the original point of it. I'm the farmer. I have cattle and crop, and all I'm trying to do is I'm just trying to add it to my containers. That's it. Just think of it from that end, and think of it from starting a square. Start with a square and say, how do I get the area of a square? How do I get the area of a cube? All of that, right? And just work your way up and refer to the video. And ideally, the best way to do it is just to start from scratch, like public static void main, that one hello world class, and just try to work your way up. But I'm not expecting you to get all of it. The point of this is I want to show, despite this being a completely separate example from once you start actually running through frameworks and everything, it's using the same ideas of it. But just look it over, and no homework. But you're just gonna have to import it and just kind of click through the logic, right? And it will obviously add on to it. But that's it.
Okay, cool.
All right.
All right. So,
All right.
All right, later.
You got this the whole thing?
Huh?
Yeah,
every-
upload this whole video,
Yeah,
right?
yeah, everything's recorded. Don't worry.
Okay.
All right,
okay, cool.
all right, later.